Welcome to the ACT Math Test 2020 Practice Review. All right, so we're going to go through each question on the 2020 practice test, but we're going to start off just by talking about what the ACT Math Test looks like. Right, so the ACT itself covers multiple different topics. Math is the second part of the test, is usually after the English section. It consists of 60 multiple choice questions, which is given over 60 minutes, assuming that you don't have an accommodation for some kind of extended time or if you're using a different format. And calculators are allowed on all portions for every question, which is different than the SATs, which has a non-calculator and a calculator portion. Okay, so when you take the test, okay, it will look something like this when you begin. Okay, so here's the topics that are going to be covered first, right? So you can see that it breaks down to be approximately 7 to 10% numbers and quantity, so just basic number calculations. 12 to 15% is algebra. We have little functions in geometry of similar, question quantity. Slightly smaller for probability and statistics. And if you notice, the biggest section here is what's called synthesizing and applying all the above skills. So almost half the test consists of, can you take multiple disciplines up here or several ideas within one discipline and put them together into more complex problems? So not only do you have to understand the fundamentals, but you also have to understand how to apply them and maybe change the basic understanding to be something a little bit more complex. Okay, so we'll be focusing on those during the practice test. Okay, so again, this is what the test will look like when you start off in the math section. So this is Form 1874, which is the 2020-2021 practice test. And I have a link here at the bottom, which I will also be posting in the description. So if you need to access the actual test that we're going over so you can practice on your own, then you can click on the link in the description below. Okay, so we're going to hop into this. One thing I am going to ask, if you can, is if you could hit the like button on this video and subscribe. I'm trying to get the word out about this video to as many people as I can so that I can help as many people as I can. So by liking and subscribing, you will spread the word, and it will help it to show up in the YouTube search so that more people can find this, and hopefully it will benefit the masses. Okay, so let's get started. Okay, so for problem number 1, we are going to say that Marcus's favorite casserole recipe requires 3 eggs and makes 6 servings. Marcus will modify the recipe by using 5 eggs and increasing all other ingredients in the recipe proportionally. What is the total number of servings the modified recipe will make? Right, so this is a proportions problem, right? And so it's a quick answer if you kind of stare at the numbers, but just as a quick explanation, right? What we're doing here is we're comparing the number of eggs to the number of servings, okay? And in this case, it looks like it's going to be 3 eggs makes 6 servings. And then if we compare that to what we just changed, it looks like we're going 5 eggs, which I have it going across the top, and that will make an unknown number of servings, right? So you might notice that there's a nice easy pattern here. 3 becomes 6 by doubling, so 5 becomes 10, which is our correct answer, by doubling, right? But if you want to do the actual algebra, 3 times x makes 3x, 6 times 5 makes 30, right? If I use cross multiplying, right, and that makes x equal to 10 when I divide both sides by the 3, right? So however you get it, the correct answer here is C equals 10 servings, okay? Problem number 2, the 35-member history club is meeting to choose a student government representative. The members decide that the representative, who will be chosen at random, cannot be any of the 3 officers of the club. What is the probability that Hiroko, who is a member of the club but not an officer, will be chosen, right? So in this case, this is a probability problem. Whenever we do probability, we always do what we call the desired outcome. So I'll put this as desired, okay, over total, right? So what we want to happen over how many choices I have, right? So in this case, there's a 35-member history club, but 3 of the members are officers. So we only have 32 members that are eligible for this student government representative. So the total number of students is 32. And in this case, Hiroko is only one of those members, right? So he only represents 1. He is the desired outcome. So 1 out of 32 would make that choice K. Okay. Problem number 3. For what value of x is the equation 2 to the 2x plus 7 equal to 2 to the 15? True. Okay, so this is an exponent problem, and simply put, what you really have to do here is if the bases are the same, in this case they're both 2, then the exponents have to be the same. So as a simpler example, if I were to say 2 to the third equals 2 to the x, okay, you can say 100% for sure that this x here has to also be equal to 3, right? So if you notice what's happening, if the bases are the same, I can really just set the exponent parts equal to each other. So I'm going to do that with these exponents. I'm going to say that 2x plus 7 has to be equal to 15. Okay, and then if I subtract the 7 over, it looks like I will have that 2x is equal to 8. And if I divide, I get that x is equal to 4. So it looks like choice B is going to be our correct answer for problem number 3. Problem number 4, let the function f be defined as f of x equals 5x squared minus 7 times the quantity 4x plus 3. What is the value of f of 3, right? This notation here is called function notation. And what it means is anywhere that x exists in f of x, we're going to replace it with a 3. So here's what this will look like. F of 3 is equal to taking this expression and plugging in a 3 anywhere that I see x. Okay? And then we just have to be careful that we do our order of operations correctly. Okay? So it's going to look like this. Okay? So I replaced the x with x squared with a 3. And I replace the x next to the 4 also with a 3. All right, so when I'm doing this type of problem, I have to, again, be careful. So I'm going to start off inside the parentheses. I'm going to multiply this as 12 plus 3, which is 15. Okay, then I'm going to bring everything else down. This says minus 7. Okay, the parentheses became 15. And then I'm also going to simplify this first part. Right, be careful with the first part. PEMDAS says do exponents, then multiply. So I have to do 3 squared. Okay, which is 9, okay, times this 5, and that's going to make 45. Okay, and then I could do 7 times 15. Okay, so 7 times 15 I have to multiply before I subtract, right? So 7 times 15 is going to be 105. Okay, and this is a 45. So 45 minus 105. Again, this is something, double check it on your calculator. Be sure that you're right. Looks like it's minus 60 in this case. So that's going to be our correct answer for this one. F of 3 is minus 60. Okay. Problem number 5. A wallet containing 5 $5 bills, 7 $10 bills, and 8 $20 bills is found and returned to its owner. The wallet's owner will reward the finder with 1 bill drawn randomly from the wallet. What is the probability that the bill drawn will be a $20 bill? Okay. So assuming that you returned everything, right? Again, this is that same situation where probability is desired, right? Okay, over total. Okay, so the total number of bills, if I were to count how many bills there are 5, 7, and 8. Right, that looks like 20 total bills. 8 and 7 is 15, and another 5 makes 20 total bills. Okay, of those 20 bills, right, it looks like we want the desired outcome to be $20 bills, and we know that there are 8 of those. Okay. So if I take this now and reduce it, since I don't see 8 over 20 on the list, all right, if I reduce this by dividing the top and the bottom by 4, it looks like I'm going to get a 2 and a 5, right? And there's your answer, choice letter D, okay? So probability, shown up twice already in the first 5 problems, okay? The ABC Book Club charges a $40 monthly fee plus $2 per book read in that month. The Easy Book Club charges $35 monthly fee plus $3 per book read in that month. For each club, how many books must be read in 1 month for the total charges to be equal? Okay, so the first thing we need to do is write an equation that represents each of these. I will point out that you could just guess your way through this. You could pull out your calculator and do, okay, $40 plus 2 times 1. Okay, well, that's $42. And then I can check that with the Easy Book Club as well and see if I get the same number. Right, and I can do that for each of these choices, and that's a valid way of getting the answer. Right, but I'm going to show you the algebra way, which is, I think, just as quick, but we'll show your work as well. Okay, so in this case, if I'm going to say per book, and I don't know how many books, right? That's the question. How many books? We don't know. So I'm going to say that X represents books, right? How many books we're going to read. Okay, so if I write an equation for the ABC Book Club, I'm going to say that it is $2. Okay, and that is going to be times the number of books. Okay, excuse me while I get my pen back, right? $2 times the number of books, which is X, plus I'm going to get charged a $40 monthly fee. Okay, so that's 2X plus 40. Okay, and then the other group, the Easy Book Club, is going to be $3 per book, so 3 times X. Okay, and then I'm going to add to that the $35 book club. Okay, and what they want to happen is if this is ABC and this is Easy Book Club, we want the charges to be equal to each other. So I would like these expressions to be equal. Okay, so what I'm going to do to solve this is to subtract the 2x to the right. That's going to be now an x. Okay, and then I'm going to do this on the same step just to save me an extra step of work. I'm going to subtract this 35 back over here, right? And that looks like it's going to be a 5, right? So X represents the number of books. It looks like when we have 5 books, choice letter H, that means that the charges are the same, okay? All right, problem number 7, geometry. If in a parallelogram ABCD, AC is a diagonal, right? So there's a lot of vocabulary showing up in geometry, so you got to maybe go back and brush up on that, okay? Diagonal just represents connecting together two vertices. So if C is a vertex and A is a vertex, that's where angles are located, right? Where two lines come together, right? If I connect together two vertex lines, okay, that are not on the outside edge of the shape, that's what a diagonal is, okay? So it's saying that if AC is a diagonal, the measure of ABC is 40, so they've put that in the picture for us, and the measure of ACD is 57, right? What is the measure of CAD? Okay, so here's kind of a couple things we can point out about this. The first one is make sure you can understand how to read the name of the angle, right? So CAD represents starting at C, going down to A, and then up to D, right? So if I trace that C to A to D, that's this arc here that they have the question mark in, right? So make sure that we can do that. We really care about this one right here, okay? So there's a couple ways that we can do this. Okay, the first one is going to be to focus on the fact that I have a triangle, right? Right here is a triangle, okay? And we know that triangles always add up to 180 degrees. So if I can figure out what this angle is, right, the one by the vertex D, well then I know that this 57 plus that angle plus this angle CAD have to add up to 180, right? So I think that's probably your easiest strategy. In order to do that, though, you have to know something about parallelograms, and that is that opposite angles, in this case angle B and angle D, are across from each other. They're not connected by a line, and that those angles, okay, are always equal to each other. So I know that this has got to be 40 degrees because it's opposite from B, right? So now what I know is that this unknown angle, which I'll just call X, plus the 40-degree angle, plus the 57-degree angle, that those three angles should add up to 180 because they are part of a triangle, right? This triangle CAD, okay? So it looks like here I have a 97 degrees if I add together the two that I know, okay? Oops, that's a plus sign, okay? Let me fix that. I'll just redo this step, okay? So we'll say X plus 97 is equal to 180. Right, and that looks like we have, if we have 97, that we're going to have, 83 degrees left over. Right, so X is going to be equal to 83 degrees. Right, so that's going to be your choice, letter D. Okay, so let's put a big circle around D. Okay, so that's going to be your answer for that one. But again, you're going to have to go back and take a look at your parallelogram rules in order to get that opposite angles are congruent rule. Okay, all right, next problem. When X is equal to 1/2, what is the value of 8x minus 3 over x, right? So this is a plug-in problem, right? If they're telling us what x is equal to, and we just have to plug that in both of these x locations, right? The catch here is that since x is a fraction, you're going to have to know your fraction rules. Okay, so we're going to do this two ways, right? The one is the fraction way, and then I'll show you the calculator way, since you are allowed to use a calculator on this test. So the first thing I'm going to start off with is plugging in the 1/2 everywhere I see x, okay? And I'm just going to simplify the top of this, right? The top of this says 8 times 1/2. Well, half of 8 is 4, so this really says 4 minus 3 over 1/2, right? Notice how I'm not being intimidated by a fraction within a fraction. I'm just simplifying the top, right? This is going to be 4 minus 3, so this is 1 over 1/2, okay? Now, you might be saying, how do I handle this, okay? Remember that a fraction bar, like this one right here, is really just a division symbol. So if I rewrite this, this really says 1 divided by 1/2. Okay? And that's nice because if you remember, dividing by a fraction like 1/2 is the same as multiplying by the reciprocal of that fraction. Well, 1 times 2 is just 2, right? So I'm going to say that my answer here is 2, okay? So that's going to be your final answer, okay? If you want, you can also use the calculator here, right? So let me pull up my calculator, right? So my calculator, I can do this same thing, okay? Let's see if I can move it out of the way, right? And so for the calculator, I can type in the same thing, and I can say 8 times, okay? And instead of writing 1/2, I know that 1/2 is 0.5, okay? Minus 3, okay? The reason I'm showing you this is because you might be tempted to do this, okay? And then say, okay, I'm going to divide by 0.5, right? That looks like what our problem says, right? You have to be careful, though, because if I were to look at this, PEMDAS says I got to do 3 divided by 0.5 first, right? It's not going to simplify the whole top, right? It's only going to simplify the 3 with the 0.5 instead of everything. So if I'm going to do this, I'm going to have to be careful and say that I want this entire top part, so I'm going to insert a parentheses, right? Whenever you're typing fractions into a calculator, okay, you want to make sure that each part of the fraction is separated. So I'm going to say the top part now has to be done first, and once I have that final answer, I can divide this by 0.5, right? So it is a calculator, accessible problem, but just be careful when you're typing in fractions that you're putting the numerator and the denominator in separate parentheses. So the calculator knows that that's exactly what you want it to do, okay? All right, so let's get back to the problems, all right? The answer here is 2. All right, problem number 9. It says, in the standard XY coordinate plane, okay, what is the midpoint of the line segment that has endpoints of 3, 8 and 1, -4. Okay, so if you remember from geometry, there is a rule for this. Here's what the rule says. Okay, midpoint is the middle of a point. So if I literally have 2 points, okay, in this case they are 1, -4, okay, and 3, 8. Okay, the midpoint is literally what point is exactly in the middle of them. Okay, all right, let me get back to my pen again. Okay. There we go. All right, so 3, 8. Okay. And the midpoint is just exactly halfway in the middle. Okay, so this I'm just going to call M for now because we don't know what it is. Okay, so if you use the formula, there's a formula that says if you add together the x coordinates, right, which I'm using this little subscript x1 and x2, and I divide by 2, that's going to be the x value of the midpoint. And then if I do this exact same thing for the y values, y1 plus y2, right, so take the 2 y coordinates and divide by 2, that will be the y value of the midpoint, okay? So if I do this, here's what I'm going to get, okay? If I add together the x coordinates, which are the 1 and the 3, right? If I add those up, 1 plus 3 divided by 2 is really 4 divided by 2. Well, that's a 2, okay? If I do the same thing with the y's, I'm going to say -4 is a y. This is a y, right? And then 8 is also a y. So -4 plus 8 divided by 2. Well, that's 4 on the top divided by 2 is 2. So it looks like the point 2, 2 is the midpoint. There we go. We got our answer, okay? There's actually an easier way to do this, right? If you don't remember this formula when you get to the test, just remember what midpoint means. Midpoint means that this point is the exact point where this little segment here, this first one, is equal to the one on the other side, right? Midpoint makes 2 equal pieces. So what that means is, hey, that this midpoint is going to be kind of like what you would have to do. Like if I wanted to count, like to get from 1 to 3, what's halfway in between 1 and 3? Well, I'd have to go count by 1, count by 1. So this would have to be a 2. And then if you think about, again, if I'm counting from -4 up to 8, I'm actually counting 12 spaces, right? So I'd have to go up 6 and then up 6 again to get to this 8. Well, if I went up 6 from -4, right, that's going to be putting me at 2, right? So again, if you think about the distances, if I go from 1 to 3, I'd have to go a 1 and a 1. Well, here I'm going to have to go a 6 and a 6, right? And that would get me to the same place, right? And that makes 2 equal distances, okay? So that's another way to think about this problem if you don't happen to remember the formula for the midpoint, okay? All right, so here's the last one in this video. We'll stop at problem number 10, and then we'll start a whole new video for 11 through 20. Okay, this one says the fluctuation of water depth at a pier is shown in the figure below. One of the following values gives the positive difference, okay, in feet between the greatest water depth and the least water depth shown in the graph. What value is it? Okay, so first thing I'm going to look at is what's on the axis. I see that the vertical axis, the y-axis, represents depth, right? So that is what's being referred to in this problem. You can see they're talking about the greatest depth and the least depth. So I really care about what's happening on the y-axis. Okay, and then the other thing I'm going to notice is that there's some vocabulary showing up in this problem. Let me grab my highlighter. Right, I see positive difference. Right, so positive difference just means if I subtract the two numbers, the word difference means subtract. I care about the positive version, and here's kind of what I mean by that. If I say 3 minus 5, I get negative 2. If I flip these over and say 5 minus 3, I get the same number, but I get the positive version. So the positive difference is just going to say, put the bigger number first, subtract off the smaller number, and that will be the positive difference. So don't be thrown off by this language. It just means subtract them in a way that you'll get a positive answer, okay? So all I'm going to do for this problem is say the least water depth is the lowest point, and it looks like right here at 6, right? It hits a couple points where it gets down to 6 feet, okay? And then the highest one, it looks like is where we start here at 0 hours, right, which is 6 a.m., and then maybe again over here at 14 hours, right? But it looks like 12, right? So I'm going to say my earliest one. Let's get rid of my example here, okay? If I say 12 hours is my highest depth minus 6 hours, which is my lowest depth, it looks like the positive difference between those is going to be 6 hours, okay? So again, we're going to stop here. This is problem up through problem number 10 of the ACT 2020 practice test. We will continue again next in the series with problems 11 through 20, okay? And we'll eventually get all the way up to problem number 60.